Alright, we have a couple examples in this video where we are going to add or subtract rational expressions. When you are adding and subtracting rational expressions, you need a common denominator. So that's the first thing that you work on. You look at your denominators of the addition or subtraction problems, and you want those all to be the same. We can do that with multiplication. So first thing I'm going to do is I'm going to focus on this first denominator. There's a y and a z here. Our second fraction has a z and an x, and the last one has an x and a y. So I'm going to start with the x's just so it's alphabetical and I don't lose track. I can see we have an x in this denominator. We have an x in this denominator, but we do not have an x in this denominator. So that is the first thing I'm going to do, is I'm going to multiply this fraction by x. Now if I multiply the bottom by x, I also have to multiply the top by x. Now because the top has two terms, I'm going to put parentheses around it and multiply by the x like that. Alright, so now all three fractions have an x. Now I'm going to move on to the y's. This first one has a y, the last one has a y, but the middle one does not have a y. So I'm going to go ahead and multiply this fraction by y. Again, the numerator has two terms, so I'm going to put parentheses around that, and I'm going to multiply that by y. Remember what you're doing. If you multiply the denominator by something, the numerator has to get multiplied by the same thing. Alright, so now all three fractions have an x and a y. Now look for z's. This one has a z, this one has a z, this one does not have a z. So I'm going to multiply this one by z, the numerator as well, but again, because there's two terms, I'm going to put parentheses around and multiply by the z out front. Okay, so we are going to rewrite this problem because it's starting to get sloppy. I know that our denominator is an x, y, z. Now the numerator, we want to go ahead and simplify what's happening in the numerator. We have an x times a y minus z. So let's just go ahead and distribute that x. We have xy minus xz. Alright, so that's our first fraction. Minus. Now the second fraction, I know the denominator is xyz. And then I'm going to go ahead and distribute that y. So we have yz minus, and I'm going to say xy just so I'm keeping everything alphabetical. Alright, bring down your next minus sign. And our third fraction, the denominator is xyz. The numerator, when we simplify, we're going to multiply that. But again, I'm going to alphabetize these. So I'm going to say xz minus yz. Okay, so that looks a little bit better, right? Or maybe we think it doesn't look better. So we're subtracting three fractions. We're going to subtract left to right. The one thing I do know is that the denominator is going to stay the same. It's going to be the xyz. So here's where this is going to get, this is going to be kind of a pain. But that's okay. We can stick through this. First we're going to combine all this up here. And these subtractions, we're going to have to pay attention to that. So first we have the xy minus xz. Now we're subtracting a yz, so minus yz, and we are subtracting a negative xy. So that negative becomes plus xy. So that's what you have to be careful about, are ones like that. Alright, now we are subtracting xz, so minus xz, and then we are subtracting a negative yz, which becomes plus yz. Okay, whew. Now, to simplify, we want to look to see if we have any like terms we can combine above. I mean, I already know what the denominator is. We already took care of that. That's an xyz. But do we have anything up top that can go together? So here's an xy. I'm looking for any other xy's. Oh, here's another xy. So xy plus xy is 2xy. All right, now I have an xz. Here's minus xz. Here's another minus xz. There's two of them, so minus 2xz. And then we've got this minus yz and plus yz. Well, I like that because if you subtract a yz and add a yz, they cancel each other out. All right, so our answer actually looks much better than I thought it was going to, so that's good. We have 2xy minus 2xz over xyz. So how can we possibly simplify this? I can't cancel x's here, I can't cancel z's here. This subtraction keeps this term stuck to this term. So this is when you want to think about factoring. These two terms have some common factors. So I'm going to go ahead and pull out a 2, and they both also have an x. That leaves me with y minus z over xyz. The reason why we wanted to do that is now I have an x out front separated by multiplication, no addition or subtraction. I can cancel that x with that x. So our final answer is 2 times y minus z all over yz. And this will be our final answer. All right, that last example got a little long, but now that we've talked through it, these will start to get a little bit faster. So we have a subtraction problem. This denominator is z minus 4, that denominator is z plus 4. Go ahead and put parentheses around those so you know that those are stuck together. So to get a common denominator, on this side I'm going to say, well, this one needs the z minus 4 on the top and bottom. The one on the left needs the z plus 4. Z plus 4. So now both fractions have a z plus 4 and a z minus 4. We're ready to rewrite the problem. This rewriting the problem is so important. We know the denominator is going to be, well, not x because it's a z. Z plus 4 times z minus 4. And then 1 times those is just really z plus 4. Minus, now we have to do the other fraction. We have a z plus 4, z minus 4. And then 1 times that z minus 4 is just z minus 4. All right, so we have a common denominator. So we can do the subtraction, and we know we're going to have z plus 4 and z minus 4 for our denominator. And then the numerator, we're going to combine all of this. So we have a z plus 4, and then we have minus a z, so minus z, and then minus a negative 4. So minus a negative 4 becomes plus 4. And then we look for any like terms we can combine on top. Well, that's kind of nice because z minus z actually cancels out. So we're left with just the 4 plus 4, which is 8, over z plus 4, z minus 4. And when you look at that, I can see that we have an 8 on top. There's no 8s on the bottom to cancel that with, so this is our final answer.